Somewhere in a field by the coast in the north of England is Britain's best kept industrial secret. It looks like a vision of the fossil fuel past, but this refinery is one of the answers to one of the biggest questions of all: how to eliminate carbon emissions and to save the planet. If that sounds unexpected, then it is because this is the story of where batteries come from. And this, increasingly the biggest economic issue of the 21st century, is probably not the story you think it is. The London Metal Exchange. For more than a century, this is where the world has come to buy and sell in the ring. So this board has been kind of going like haywire.
It's been flashing a lot, that's right, yeah.
Today, it is the pursuit of critical materials to fuel a new green industrial revolution that's taking financial markets by storm. Well, if the world is in a race for critical materials, this in a sense is one of the front lines, where the prices of those metals are being set.
We've seen a phenomenal increase in demand for the likes of lithium and cobalt. There's a lot of investment flowing into the sector, as you might imagine, and clearly prices have been extremely volatile in recent years.
This is about money, it's about jobs, it's about the fate of the planet. Because to some extent they all depend on these things: batteries, cells. Whether in your smartphone or in an electric car, they are the energy source of the future. But how are they actually made, and what's inside them? To answer that, I've travelled to the one place in the UK where we have the equipment to make them, where you have to wear protective clothing, not to protect you from the machines, but to protect the machines from you.
Here at UKBit we make a 21700 cell, so 21 millimetres in diameter, 70 mil long, used in lots of electronic components, so laptops, things like that.
If everything goes to plan, there will soon be a lot more of these machines around the country, in a fleet of so-called gigafactories, massive plants taking critical metals and turning them into batteries. Well, what is a battery? Ultimately, it is those raw materials, crucial materials like lithium, cobalt and so on, rolled up into this coil that in turn then gets covered in steel and becomes that cell that we all recognise. And this place here in Coventry, the Battery Industrialisation Centre, is a place where companies will come and learn how to build the gigafactories of the future. Is this kind of high-value manufacturing when you're talking about batteries?
Yes, it is. So it's very skilled. It's very capital-intensive as well. So to build the factories in the first place costs billions of pounds. And there's been some recent announcements in the UK, a couple of gigafactories that are going ahead.
But what you've got here is kind of the closest thing to a gigafactory that we have, really, isn't it?
It is the closest thing we've got to a gigafactory in the UK. All of the equipment that we've got here, Ed, is the kind of equipment you would find in a gigafactory. This is a typical cell, a cylindrical cell.
Okay.
There are various different forms of cell, which we could show you. Yeah, sure. So these are the kind of cells that we're making for our clients at the moment. We make different formats.
This could go in an electric car?
Yeah, so in an electric car. So typically in a large electric car battery, there may be 7,000 or 8,000 of these cells.
But it's only when you look inside the batteries that you begin to see the materials the world is racing to procure.
And inside there, we've got then layers of cathode, or anode in that case, and cathode material. And you can now see that unwinding, and you can see those layers. So one side is the side that is, in this case, a graphite, and the other side is
that's your graphite, and then that's your kind of lithium and other things.
That's exactly right.
Amazing. But there is a problem, because according to internal calculations provided to the government and seen by Sky News, Britain's gigafactory ambitions may fall short of what it needs. At present, the UK has about 2 gigawatt hours of battery production. By 2030, it is projected to have about 70. But if it wants to keep the car industry in its current state and protect jobs, it may need more than double that, 175 gigawatt hours. And given batteries are all about the interaction between the materials in that cathode and anode, positive and negative, it will also need enormous quantities of cobalt, procured from ores like cobaltite, and lithium, the heart of the battery, so volatile it can only be processed when turned into salt, like lithium carbonate. The leaked data shows the UK's requirements for lithium, cobalt and graphite for anodes. Currently, the bars are so small you can barely see them. By 2030, they could be 90 times higher, a 9,000% increase, raising a question. Where will it all come from? Currently, most of the world's lithium comes from the deserts in Australia and here in Chile, before being transported all around the world, usually via China.
We've built the pilot plant in it, and you can see the...
How is Britain doing on this front? To find out, I've travelled to Cornwall, where the most promising reserves are to be found.
The starting process is we take the crushed rock, which we feed into the plant, and it goes up the conveyor belt.
You've got this whole process.
Processed up there.
Yeah.
It's all refined, and then this is it. This is the end product, the final lithium carbonate.
So that's lithium carbonate.
That's it there.
And that's stuff that you could put straight into a cathode which goes into a battery, and that's the key ingredient for
it's
electric
probably
cars.
about 4 mobile phones just here. It's a bit of a transformation to take it from that to that.
Of course, this is just a demonstration plant, but this company, like many in the sector, has big dreams.
It's totally a lithium gold rush. You know, no other commodity on the planet is growing by 30–40% per year. If you look at the UK, we've got a £96 billion automotive industry, and that's transitioning by 2030 to completely electric vehicles. So where are we going to get all of these batteries? And in turn, where are we going to get all this lithium to supply those batteries?
And it's not just lithium. There are other materials in those cathodes too. Nickel, manganese, and most notoriously, cobalt. Scenes from a Sky News investigation 5 years ago in a cobalt mine where children as young as 4 are put to work.
A very high proportion of cobalt is mined in the Democratic Republic of Congo, so it's concentrated in one country. It's concentrated in a country that is quite a high political risk potentially, and then added to that are the headlines that you sometimes see that some of the mines are using child labour, and that adds to the what we call the environmental social governance risk that goes with it.
But remember, the cathode is only one half of the battery. What about the anode? What's that made of? The answer, it turns out, is graphite. Graphite, not lithium, is the single biggest ingredient in the batteries in smartphones and cars like this one. And where does that graphite come from? Some is mined, mostly in China, but some comes from somewhere much closer to home. This is the Humber refinery, where they make petrol, aviation fuel, and, it turns out, the critical ingredient that goes into anodes. It is the first time anyone has been allowed in to film this process. At the heart of the global battery supply chain. We are quite literally in the bowels of Britain's fossil fuel industry. There is soot caked everywhere. The air is thick with a kind of acrid steam. And it's all coming from this stuff. This is graphite coke, and surprising as this might sound, it is central to resolving climate change and getting to net zero. Why? Because pretty much every battery and every electric car in the world contains that stuff in the anode. And what is that made from? It's made from crude oil. This is the reality of green energy, the bit no one really talks about. Because the black substance you're looking at here will soon be part of the batteries powering the energy transition. If you have an iPhone, the chances are it has some of this North Sea carbon in it.
We've got 4 pairs of coke drums, so we're halfway up one pair, looking across at another pair. And what happens here is that the coke forms in a vertical solid drum. Once the drum's full of coke, we cool it down with water, which you can see the steam coming out there.
So that's the coke down there?
It is, that's the black, looks like coal.
Aren't you part of the, the problem in that there's all these chimneys here pumping out a lot of pollution?
I would turn your statement round. I like to say we're part of the solution, we're not the problem.
Even net zero is powered in part by fossil fuels, but this is not burning them, it's making stuff with them, and unusually doing it here.
We're the only people in the UK that's manufacturing it, and really the only people at any scale in Europe. And so, really for the UK it's a significant opportunity. We've got one piece of the supply chain right here around us. Right now it all gets exported to the other side of the world. There are, lots of know-how involved and trade secrets, but we've been doing it for a long time. So manufacture of high-grade petroleum coke, it might look like coal when you see it lying around, but I can assure you it isn't. It's very specialised with very specialised and very tightly controlled properties.
That brings us to a question. Right now we ship this coke from Humberside to China to be turned into anodes. Why aren't we doing that here? It is another race the UK is not winning. Which is ironic, because this country is where the battery story really began.
The EV revolution started just a couple of hundred yards from where we're sitting right here today in Oxford with the discovery by John Goodenough of lithium cobalt oxide. But if we want to be a leader, we're going to have to leapfrog to the next generation because, other countries, China, Japan, etc., South Korea, they already are very dominant in lithium-ion technology. So we can certainly play our part there. But the opportunity for the UK to be a world leader, to be a superpower, is to look to the next generation, and that would be something like the solid-state battery. There's also the sodium-ion battery.
Sodium-ion batteries, where the main ingredient isn't hard-to-source lithium, but sodium chloride, table salt. And guess what? The world leader in sodium-ion is based here in Sheffield.
We start with our 2 active materials. So we have a negative active material, which is our anode, and a positive, which is our cathode. Right. And at the moment, our sodium is in our cathode, and our anode is basically carbon.
So no lithium, no copper, no cobalt. The only problem is these batteries aren't quite as powerful as lithium ones.
We think that sodium ion gives the opportunity for the UK to go beyond lithium, to get out in front of the next generation of technology.
Does it feel like a race?
It's an arms race, right? I mean, if you look at oil, it's geopolitical, it was an arms race, right? It's all about energy security in many ways. It's not just about the market, but it's about energy security. That's national security, it's economic security, it's environmental security.
And where is Britain in that race?
Does the UK have a critical minerals strategy at the moment?
At the moment, there's no critical minerals strategy in the UK. It should have one, and the UK government are working on that at the moment.
We stand at the dawn of a new industrial revolution and a new great race for materials.
Bets are being placed. Europe is beating us to the punch.
How our battery industry evolves may shape our economy.
Hundreds of thousands of jobs in the UK depend on the automotive sector. If we as a country can't have some of that technology here, then we lose out.
Our lives, our livelihoods, our security.
You want to have control over your own destiny in terms of your energy.
This unexpected story of batteries and metals, of green power sources made in fossil fuel plants is not over. It is about to begin.